I'm Irene Darko and welcome to my YouTube channel. Stay tuned and be educated. That is a function unit within a processor that performs data processing operations using components such as arithmetic logic units, buses, multiplexers, and registers. It is responsible for executing instructions and manipulating data in the processor. The term data path cycle is often used in the context of digital circuits and computer architecture, particularly in central processing units, which is also known as the CPU, and other hardware systems where data moves through various components. Here are the key reasons why the data path cycle such on CPU performance. Efficiency. In pipeline CPUs, each stage of the pipeline depends on the data path cycle, and if the cycle is long, stages take longer to process, reducing the pipeline efficiency and causing delays. Latency. The data path cycle influences the latency of operations. Longer cycles increase the time taken for each operation, like arithmetic or memory access, slowing down the CPU's response time. And the instructions throughout. A shorter data path cycle allows more instructions to be processed amount of time, increasing the instruction throughout the overall processing speed. Parallelism. With a shorter data path cycle, the CPU can handle more parallel operations. Example, in multi-core or SIMD processors, improving performance in multi-threaded tasks. Power consumption. Longer data path cycle can lead to more power consumption as the CPU stays active for a longer period of time during each cycle. Reducing the cycle's length can help make the CPU's power more efficient. So how the CPU fetches, decodes, and then executes instructions in a sequence known as the instruction cycle. Here's a simple breakdown of each step. So the first step is the fetch. And now the CPU fetches an instruction from memory, usually from the instruction cache or the RAM. This is done using the program counter, a PC, which holds the address of the next instruction to execute. The PC is used to access memory, and the instruction at the address is fed into the instructions register. After fetching this instruction, the program counter is updated to point to the next instruction, typically in incrementing the address. To decode. The fetch instruction is decoded by the control unit, which is the CU, to determine what operation needs to be performed. The instruction also consists of the control unit. The control unit interprets the the instructions consist of an which specifies the operation and operands which specify the data or address involved. The control unit interprets the opcode and sends signals into other parts of the CPU, such as the ALU, which is the arithmetic logic unit, or register, to prepare for the next step. To execute, the CPU performs the operation specified by the instruction. If an arithmetic unit, the ALU executes the calculation. Okay. If it's a memory unit, data is read from or written to memory. If it is a branch instruction, the program counter is updated to jump to a new address. The result is stored in a registrar, memory, or output, depending on the instruction. Thank you.